Hi, good afternoon, everybody. I'll try and be as brief as I can, just to keep us on track. Yes, so this project focused on the national flood mapping capability. This in the previous previous presentation, as you saw, we worked with Ambiental, so we on their project and they on our project. So taking benefit of a mutual capability for slightly different objectives, as you'll see now. So this project focused specifically on an Express Cabinet Office COBRA requirement for near real-time mapping using all-weather radar. In the project definition and in the definition of users, we addressed three primary users, so the Environment Agency, the Civil Contingency Secretariat with a Resilience Direct as being an output portal for this kind of data, and also with the reinsurance company Aon Benfield through our colleagues at Ambiental. So we went through a series of end-user interviews where we compiled basically the user requirements, adding to those already identified at the proposal stage, and really they can be summarized into four. So looking at improving the timeliness of flood mapping using satellite capabilities to their full. And part of this is, of course, developing the national satellite tasking plan, so to use satellite capabilities in the best way to address a national mapping need. We were reusing an existing UK capability, so the UK ground station, which is a shared facility between the satellite applications catapult at Harwell and also our operators at Telespazio VEGA for the operational use of this capability. And then quite a lot of the project was focused on the precise and accurate automated flood delineation. So as a starting point, was the Copernicus EMS algorithm used by our colleagues in Italy, EGEOS. So in the Copernicus Emergency Management Service, there is an existing flood mapping software which is used, and we used that as a starting point and saw how we could adapt it slightly to the available data in the UK to make it work more effectively. Okay, so go on to the next slide. So just one slide achievements then was to develop this national flood map to take best use of the 3-day flood forecasts which currently exist, to then target where the satellite will image ahead of time. Now, currently, a lot of the problems is that satellites will often be tasked when a flood is already occurring once it's occurred. So the key point is to try and get ahead of the game and get things in place so that you can react to a forecast rather than begin imaging once the flood has occurred. So to do that, then, we need to have a concrete plan of where to task the satellite. Here, of course, we're addressing the capability of the two satellites. So I should say the national plan itself is looking to use Sentinel-1 data, 20-meter resolution, which of course gives a very large area coverage, whereas the Cosmos SkyMed system with 3-meter resolution is best used on those urban areas where that additional detail is needed to get anything useful. So in terms of overall accuracy, we hit an accuracy of over 90% when comparing with the Environment Agency's LiDAR-derived flood maps over the Maidenhead area, which was our test data set. And we also showed that the 4-hour turnaround from image acquisition to precise flood delineation was indeed possible. So going into some of the detail then, as I said before, the sensible use of satellites is to use them in a cost-effective manner. So we can use Sentinel-1 data, which is free, which gives very broad and large area coverage to cover very large floodplain type situations where flood mapping is indeed needed, but maybe the precise detail, the precise zoom in and detail of the precise location of that flood can be compromised and optimized in terms of getting larger coverage. So for those areas where the higher resolution imagery is needed, we developed this national high-resolution priority flood mapping map in collaboration with the Environment Agency. Those areas of greatest concern and which were urban were then mapped, and then we could then, based on this map, develop what we call the bus timetable. So for any day of the year, we know which satellite image to acquire to cover the entire England area studied in this project from the Environment Agency. Excuse me. So once that is done, then you can then quickly target an area, and using, for example, as was explained in the previous project, looking at flood forecasts, that can of course be developed further in phase 2, but in this current phase 1, we read off basically the flood forecasting centre's advice of a flood forecast and no more. But as was explained by my colleagues at Ambiental, we can obviously refine that, and you can tweak exactly where the imagery could be taking into account various other data sets, such as from flood modelling. So the capability is focused on this near real-time downlink of data. So basically, in this image here, you can see the satellite coming towards the UK, and then the pre-designed area has been put into the system. It images that area, and in the same pass, directly downlinks the data to the ground station. So within a few minutes, the actual satellite image of an area that, according to the forecast and the plan, is likely to be flooded has already been planned and has been taken. From that step on, then, we can then look at doing the flood mapping themselves. And here I show both the Carlyle and Thames Valley test sites. The Carlyle site indeed was used by the previous project, and that was our contribution to that project. In this national flood map analysis, the aim was to look how we can map flood maps over wide areas. So we looked at, in this case, if the mouse works, yes. We looked at a couple of sites. So in the Thames Valley, there's 2 frames overlapping. So the challenge there is to be able to do multi-frame flood mapping in a coherent manner and to give a complete overall picture of the flood as was imaged by multiple frames. And that was done with reference to the 2014 February flood event, which was imaged also by the Environment Agency's flown LiDAR system, so a very accurate delineation of the flood at the time. And that was then the flood mapping that we obtained was compared with that, and we achieved over 90% accuracy in the mapping of the flood through this methodology. I should add that one of the innovations we made over the EMS flood mapping method was to use coherence mapping. So this is using the coherence between 2 SAR images to guide the elimination of what's called false positives. So in some cases, using SAR imagery, areas which are smooth or dark to the SAR can appear like a flood, although they may only be a runway or a motorway, which is smooth. So using the coherence mapping, you can identify these areas which are unchanged from one date to another, and therefore refine the actual flood map that you're producing. And the times I mentioned before included using coherence mapping to eliminate false positives. So it's quite a complex process which incorporates not only a single image, as is often the case in flood mapping, but also a reference image, which does exist for all of the UK. So we had a very thorough engagement with users. We hosted an event at our offices down in London, along with Ambiental, where we brought in a number of users, not only Environment Agency themselves, but also looking further afield with DEFRA and Natural Resources Wales, for example, and also looking forward in the commercial aspect of this project, seeing how this data could be used for the insurance industry. And this simulated a lot of interest. I think some of the quotes Ambiental already showed, but basically we're going to try and take all that on board in the design of the second phase of the activity. So the benefits for the end user, in terms of challenges faced by the Environment Agency. Well, urban flood mapping was certainly one of them. This optimized use of Cosmos SkyMet data in the highest resolution will aid the urban flood mapping. It is on its own, of course, not the full answer, and it's clearly localized mapping, such as from UAVs or from combining other open data or flood mapping and flood modeling, is certainly part of the main story there. The other elements which we further addressed and moved forward was certainly on automation of flood mapping methods, so introducing further flood mapping methodologies, but also looking to do that in an automated manner in phase 2. And primarily, like I said before, the main benefit was that ability to go beyond the single frame in a reliable method, which then, of course, can be scaled up quite easily to a national scale if we go beyond 2 frames to a national scale, combining Sentinel-1 and Cosmos SkyMet data. So from the SSGP involvement, certainly the funding allowed us to explore these in great detail and to try and identify exactly how we should be doing this on a national scale and how we can further automate that in the future. So economic benefits, savings, first of all using a combination of satellite resources which exist, be them the Sentinel-1 free data, so allowing us to cover the majority of the UK at no cost, and then just using the high-resolution commercial satellites only when most needed on the urban areas. In terms of operationality, low latency is possible due to the use of the ground station, and flood map extension can potentially be done within even 30 to 40 minutes of the acquisition, not to the same detail as done in this project, of course, but certainly a great advance over what is currently available to the end user community by using the ground station. In terms of social benefits, so it's all about getting the information out there rapidly, and that's something we want to look to further develop in the next phase, where we can get information through web-based services to a much wider community as well. The service is, of course, green. There's no persons on the ground needed. There's no flying of any aircraft needed. It's all using existing spaceborne technology. So taking this forward, a couple of business models have been looked at. One is a conventional or per-based pricing method. So here the cost will be driven, 2 minutes, okay, thank you. Cost will be driven by the actual imagery consumed. So the more floods that may occur, the more it will cost that year. This is more like the current system where everything is reactive, so requiring things to be stepped up on demand. Whereas a subscription-based service, the price can be driven down when a number of subscribers are available. So if we look beyond the current phase where we've addressed mainly only the insurance industry and the Environment Agency, if we can look to broaden that to include critical national infrastructure, we can also broaden the amount of users, and therefore the unit cost to each can be brought down. So in conclusions then, robust methodologies were developed for wide area national tasking and processing of SAR imagery. The methodology, including coherence change detection, certainly improved the situation on urban flooding compared to what is produced routinely using Copernicus EMS, and also using a ground station, near real-time refresh rates as set by the Cabinet Office could be met. Yes, I think I've said that about the coherence change detection already. So next steps then would be to fully automate this methodology on a national scale, so scaling things up from 2 frames, multiple frames, combination with Sentinel on a national scale, to improve on the forecast-guided activation of satellite imaging, and to see how we can further refine those products so that they're more consumable by a wider variety of users, especially with the insurance industry in mind, which, a flood delineation on itself it's not necessarily the most useful thing. You need to combine it with other data sets to say, what does this mean to my portfolio? What does this mean to these type of users? What does it mean to agricultural users, for example, to give the fuller picture? Okay, that's the end of the presentation. So thank you for your attention. Any questions?
Looks like no.
No? Okay.
Thanks very much.